So let's chat a little bit about roots of complex numbers today. And so when we're chatting about that, what would you do? No, it's fine. What would you do for number 1 here? You should be able to handle that one relatively easy. How would you solve that? Go about solving that one. Subtract 3 from both sides. So minus 3 and minus 3, and then that gives me 2x equals negative 3. Then divide by 2. And then that gives me an answer of x equals negative 3 halves. Correct? Not setting the world on fire. Okay? What about number 2? What would you do in that one? Square root both sides? Okay, what do you get for an answer? Nope. X equals plus and minus 4? Okay. Why did I know that the first answer of 4 was wrong? What? Why do I know just from the start of that problem that there's 2 answers for that one, and the start of number 1 that there's 1 answer for that one? Nope. Okay, so then why did I know that there was only 1 answer in the first one? Okay, what do we call that number? So like here in this first one, I'll put it in orange. In here, this first one, it was a 1, and in the second one, it was a 2. Because it's the D word. The D word. Some people probably put some in their armpits this morning. Not deodorant, but it is a form. It's a brand of deodorant. Degree. Yep. Degree. Yep. Next clue is going to be it's like 50 some of them like, outside.
What?
Duh.
What the heck am I doing right now?
Okay. So the degree of a polynomial, which is the biggest exponent. Okay, degree is the biggest exponent. Also tells you how many answers you should get in the end. Okay? So in that first one, the degree was 1, we only get 1 answer. In the second one, the degree was 2, I need to have 2 answers. If I don't have 2 answers, I'm doing something wrong. Okay? Third one, how many answers should I get? Should get 2, because the degree is 2. How am I going to go about solving that one? Can we factor it? Are there 2 numbers that multiply together to be positive 5 and add to be negative 2? There should be positive 2. No? Okay, so I can't factor it. Shnikes. Now what? Quadratic formula. X is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Right? So that is negative 2 plus minus the square root of negative 16. The square root of negative 16 is 4i. That's all over 2. So the 2 answers that I get here are negative 1 plus 2i and negative 1 minus 2i. Okay, so I still get the 2 answers there. We just write it as -1 plus minus 2i, but really that signifies 2. Okay. So we got quadratic formula that we can fall back on too. What about number 4? How many answers should I get in the end? 3. The degree is 3. Biggest exponent is 3. Okay, how am I going to get them? What would you do first? Factor out an x. We can do that. I like that. Okay, so if I factor out an x, that leaves me with x times x squared minus 3x plus 2. Right? Then what? Can I factor it? This one is factorable, right? Yep, because two numbers that multiply together to be positive 2 and add to be negative 3 are negative 2 and negative 1. Then what do I do? Set them equal to 0. Okay, so x is going to equal 0. X minus 2 is going to equal to 0. X minus 1 is going to equal 0. Okay. And so then that gives me answers of x equals 0, x equals 2, and x equals 1. Yes, indeed we do. Okay? Love it. What about that one? What do we do on that one? What? Cube root right off the start? No, why not? Variable's not by itself yet. So first we should subtract 8. Oops, wrong color. Okay, then what? Then cube root it. Cube root of x cubed. X. Cube root of negative 8. Negative 2. So this was x equals negative 2. But how many answers do I need here? I need 3, right? Right? That only gives me 1. Ruh-roh. What? I don't know. Right? Because really what we're thinking here is this is, if I were to look at this graph, no, we can just graph it. If I were to look at this graph, it would look something like this. Right? Actually, I don't think there's even that big of a hump in it. I think it's just kind of like, actually, think here now. Because it's shifted 8 to the left. So it's really like this. Looks like that. And we're looking for the places that it crosses the x-axis, right? Okay. So one of them is real, the other two are imaginary. Because it's got to have 3, because we just said the degree is equal to the number of ones that we can do. Okay? So, with that being said, let's bring in some DMT back into this. Okay? So let's think about it in terms of De Moivre. Okay? using de Moivre's theorem, because we've got an exponent, right? So if I think about this in terms of de Moivre, if I go from x cubed equals -8, and then we take the cube root on both sides, right? So if I take the cube root, that's the same as taking something to the 1/3 power. And now what that's done is that's given us de Moivre's theorem, because we can take -8 and we can make that be a complex number. What would the complex number be for -8? Complex number for -8. Need a real part and an imaginary part for the number -8. What? Nope. For -8.
8i squared.
Nope. For -8, for the actual number -8, I need that written in complex form. -8 plus 0i. No, you said -2.
Oh, did I?
Yeah. But if I want to apply DMT, what form does my complex number have to be in? It's got to be in trig form. Okay? So we need to convert -8 plus 0i into trig form. Go for it. You convert it for me and see what you get. Convert this right here, you're going to convert this into trig form. Go. What do we got for -8 plus 0i in trig form?
8 times the cosine of 180 degrees plus 5 sine 180 degrees.
Everybody agree with that? Why is it 180, says Tess? Why is it 180? Really, it's not even in any quadrant, right? Because if I go on my, so this would be my real and imaginary axes, that puts me out there, right? Straight out 8, which has an angle of 180 degrees. Okay, because it's on the x-axis, or on the real axes, I should say, in the imaginary plane. Yep. Okay. All right. Now we can apply de Moivre's theorem to that. So if I apply de Moivre's theorem to this, I get x is equal to what? 8 to the 1/3 power times cosine of what? 180 times 1/3 plus I times the sine of 180 times 1/3. 8 to the 1/3 power. 2 180 times 1/3. 60. Agree? Okay. So, bring this back up now. So we have one of them at 2 times the cosine of 60 degrees plus I times the sine of 60 degrees. Which, if I had to guess, okay, that would be right about there. Because it's 2 away, and it's at an angle of 60 degrees on the imaginary plane, or on the complex plane, I should say. Agree? Okay. Now, we found one before, right? We found straight up -2, right? Or we found that as as +2. So if I change over, let me go in purple. If I change over the real solution, x equals -2. If I change over -2 into trig form, just because this first one that we just found was in trig form, okay, what would -2 be in trig form? Would it be -2 though? It'd be +2 because our values are positive. Yep. So it'd be 2 times the cosine of 180 degrees plus I times the sine of 180 degrees. Which that would be right there. Right? Or this one is also straight up just -2. Where's that third one? Where's that third one gonna be? What do you think? Given where those two are. What do you think?
Could it be like when you have the same point that counts as 2 because of like
It's a double? No, it wasn't. We know it's not a double because of the way that the graph goes. Okay, so I know that it's not, one of them's not a double. Yep. Okay. So where would that third one be? Below the real axis, because we're in the complex plane, Okay, so it'd be somewhere in either in quadrant 3 or quadrant 4, right? What do you know about 60 and 180 degrees? Other than that they're on the unit circle. Speaks, is that what you're going to say? Other than that they're on the 100, or that they're on the unit circle. 60 is 1/3 of 180. Okay, what else? I want to tell you, but at the same time, I want you guys to figure it out because it's right there for you. It's sitting right there for you. Where's that other one going to be? Talk about it. Talk about it. Talk, talk, talk. Talk, 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 talk. Don't just sit here and look at me. Talk about it. Discuss it. Brainstorm it.
Because if you go between 60 and 80 is 120. If you go 180 plus 120.
Say it loud, Tess.
Between 60 and 180 is 120 degrees.
There's a gap between here of 120 degrees.
So if you add 120 to 180, you get 300.
So I'd get 300. So let's just look at where 300 degrees would be. Okay? 300 degrees would be down here. Right?
I don't think it should be right either. That's the one thing you come up with.
But right? Because what did that do? It took my circle and it did what to my circle? It split it into how many parts? 3 parts. 3 equal parts, right? What roots did I take? He says hello. I don't know. What equal part, or so what root did I take for this problem? The 3rd root, right? Way back up here, we took the 3rd root. It's in red twice. Okay? We took the 3rd root, so we need to divide our circle up into 3 equal parts. So the other one is going to be at 2, comma, the cosine of 300 degrees plus I times the sine of 300 degrees. And that's where my 3 roots lie. Take one down and pass it around. Take one down and pass it around.
I never get those.
What?
I don't know how I got that.
I don't either, but that's what I was waiting on. Huh?
Just gotta think simple. Like really
Yep.
simple.
Yep. Sometimes you're thinking too much. Yeah, theirs is coming through. I think they got enough. Then one more back. There you go. Okay? Alright, so we need a plan, and we need to get it simplified. Okay? So this is actually the first example on that sheet that I just handed out. Okay? So what we're going to do is we're going to, if it says find the complex solutions to these or solve this equation in the complex form, this is what you're going to do. I'm taking something to the power of 3, so I'm going to cancel that out by taking each side to the reciprocal of that power. Okay? So this becomes x equals 27 to the 1/3 power. Now in order to do that, I'm going to have to convert 27 into a trig form number. So that's going to be 27 times the cosine of 0 degrees plus I times the sine of 0 degrees. And that, ladies and gentlemen, is going to be taken to the 1/3 power. Then, what I do is, and just following along here, so then I applied them off. And again, the typo happened, and we missed it. Mrs. Hill's too quick on the trigger. So the G's there on your sheet, those G's signify multiplication. So this is going to be 27 to the 1/3 power times the cosine of 0 times 1/3 plus I times the sine of 0 times 1/3 in degrees. Okay? So my first root here is going to be at x is going to equal 3 times cosine of 0 degrees plus I times the sine of 0 degrees. Now, somewhere either in my brain or off to the side, I'm going to say, hey, I took the third root. There's 360 degrees to get all the way around the circle. I took the third root, so I'm going to take 360 and divide it by that root. And that tells me that that is going to be 120 degrees. So now to find the other two, I would say this is going to be 3 times the cosine of 0 plus 120, which is 120. Then I have to do it a third time to get my third root. 3 times the cosine of 120 plus 120. And if I would do it one more time, I should get back to the one that I started with. Because 240 plus 120 is 360, which is also 0 on the unit circle. Okay? The kicker is you find one like normal, okay? And then you take 360 and divide it by the root. That's the difference in the angles that you're going around. So if I was taking it to the fifth root, okay, I would take 360 and I would divide it by 5. And I'd get 72. So I would add 72 4 times to get my angles. Okay? Have a good weekend. Be smart, be safe. Okay?